All right, class, in this lesson, we are going to learn to graph quadratic functions using standard form. So let's go ahead and get started. Okay, so here we have three different examples of a quadratic function in standard form. So here's one example. And if you take a look at the last value here, which is -3, and compare that to this graph, what you'll notice is that this graph actually intersects the y-axis at 0, -3. And that coincides with this -3 in the equation. Now, if you take a look at the second example here, you'll see that this equation ends with a -1. Okay, and what I didn't explain earlier is this is the c part of the function. So this first coefficient would be your a, your second coefficient would be your b, and your third component is labeled as c. And what you'll notice is that here we've got a -1, and if you take a look at this graph, it intersects the y-axis at 0, -1. Okay, and this -1 is the same -1 that we see in the equation. And then in this third example, we have -2x² plus 4x, and this time it's +1. So my c is equal to 1 this time. And if you take a look at this graph of the parabola, it intersects the y-axis here at 0, 1. Okay, so here's the question. What information does c provide about the graph of f of x equals ax² plus bx plus c? So basically the answer is the c value tells us where the y-intercept is. Okay, and the other piece of information that we can derive from the quadratic function in standard form is both the axis of symmetry and the x-coordinate of the vertex. Okay, and how do we do that? If you take -b over 2a, that's going to give you the line of the axis of symmetry, which is going to be x equals whatever this value is. And then similarly, the x-coordinate of the vertex is also obtained from this expression, -b over 2a. Okay, so let's go ahead and take a look at another example and see how this equation works in action. Okay, so in this example, we are going to graph the function f of x is equal to 2x² plus 4x plus 3. Okay, and in this process, we are going to first identify the y-intercept, then we're going to identify the axis of symmetry, and then the vertex. Okay, and by doing all those three things, plus one additional step, which I will add toward the end, that'll help us to graph this quadratic function. Okay, so let's go ahead and get started. First, let's identify the y-intercept. Okay, my y-intercept. Now, if you take a look at this function, we see that it ends with a +3. Okay, with a +3. And so because it ends with a +3, we know that the y-intercept is going to be at 0, 3. Okay, so if we were to graph that, we would put a point at 0, 3. Okay, then the next step is to find the axis of symmetry. Okay, axis of symmetry. And to do that, we're going to use that equation that I mentioned earlier, where x is equal to -b over 2a. Okay, now before we start entering values for b and a, we need to first identify what they are. Okay, so if you take a look at this coefficient, this is my a, so I'm going to say a is equal to 2. And if you take a look at this coefficient, This is my b, and my b is equal to 4. And we know that this is my c because we already plotted the y-intercept. Okay, so now what we're going to do is we are going to enter this value into this equation for a and this value for b in here. Okay, and so when we do, we're going to get negative 4 over 2 times 2. And then if we were to simplify that, we would get negative 4 over 4, and negative 4 divided by 4 is equal to negative 1. Okay, so what that tells me is that my axis of symmetry is x equal to negative 1. Okay, now you don't have to draw this in practice, but I'm going to go ahead and do this here just to show you visually where the axis of symmetry is. Okay, so this is my axis of symmetry, and I'm going to just change that into a dotted line so you realize that it's just a guide. Okay, so now we know that this is my axis of symmetry. We can next solve for our vertex. Okay, our vertex is going to be in the form of x comma y. Okay, so that's going to be a coordinate, x comma y. Now, earlier on, we said that the x portion of the vertex comes from this equation as well. Okay, and since we know what x already is, we solved it and found out it was negative 1. So now we know that my vertex is minimally negative 1 comma, and I'm going to just say y because we don't know what the y value is. Okay, now how do we figure out what the y value is? Well, we can find the y value from this equation, right? F of x is equal to this whole thing. F of x really is my y. Okay, so what that means is if I enter negative 1 for my x as my input, then whatever this whole thing comes out to will be my output, and that will equal my f of x or y. Okay, so the notation for solving this is going to be f of negative 1, okay, because my x is negative 1, so we're going to enter that in there, and we're going to say that that is equal to, and then we just go ahead and follow this function. Okay, but instead of writing x, we're going to write negative 1. So this will become 2 times negative 1 squared plus 4 times negative 1 plus 3. Now we can go ahead and simplify this. This is equal to 2 times 1 because negative 1 squared is 1. And this is going to be minus 4 because 4 times negative 1 is negative 4, and then we're going to add 3. And then if we continue to simplify this, 2 minus 4 plus 3 gives us 1. Okay, so now we solve for my f of negative 1, which is really my y. Okay, so now we know our y value is 1, so therefore my vertex is going to be at negative 1 comma 1. So we can go ahead and plot a point at negative 1 1. Okay, now a couple things. First, we identified our axis of symmetry, and our axis of symmetry cuts the parabola or the graph that we're going to draw exactly in half. Okay, so think of this as sort of like a mirror image or an inflection point. So what that means is if we have a point over here that is one interval away from the axis of symmetry, and because this is a mirror image, we know that we have a point on the opposite side, one interval in the opposite direction. So we can go ahead and plot a point there at negative 2, 3. Okay, so now you could start to see that we're kind of creating a parabola here. We've got 3 points, but what we want to do is just add one additional point to further clarify our parabola. So I'm going to go ahead and just label this as additional point. Okay, and my additional point, we want x comma y. Okay, that's the format we're looking for. Okay, so we don't know our x, and as a result we don't know our y. So we can go ahead and pick an x value. Okay, we already have an x value for -1 over here that gives us this point. We also have an x value of -2 that gives us this point here, and we have an x value of 0 that gives us this point. So the next thing we want to do is find an x value of 1, or select an x value of 1 that's going to give us some value of y. Okay, so I'm going to choose 1 as my x and plug that into the function. So I'm going to say f of 1 is equal to, and then we're going to follow this whole equation again. Okay, but instead of having -1, we're now going to put in 1 in place for x. So this is going to be 2 times 1 squared. Okay, and then just to reiterate, the reason we're putting in 1 is because we chose x equals 1. Okay, so whatever is here is going to go in place of all of my x's in this function. So this is going to be plus 4 times 1 plus 3. Okay, and if we were to simplify this, this becomes 2 times 1 plus 4 plus 3, and this gives us a total of 9. Okay, so what we just did was, for a value where x is equal to 1, okay, so this is our 1 over here, we plugged it into the equation and we got out a y value of 9. Okay, so now we know that when x is 1 as my input, my output comes out to be 9. So my additional coordinate that we're going to plot is going to be 1, comma 9. Okay, so then we can go ahead and plot that point at 1, comma 9, which is right here. Okay, and then using the axis of symmetry, we know that there's a point exactly on the opposite side, 2 intervals on this side, because this point that we just plotted is 2 intervals away from the axis of symmetry, and so we can go 2 intervals in the opposite direction and plot a point at -3, 9. So we plot a point right here. Okay, now you can kind of see all 5 points kind of shows us the shape of a parabola. So we can go ahead and graph that. And there's our parabola. Okay, we can go ahead and resize this and get this to kind of fit on the dots here a little bit. I think that pretty much gives us a nice parabola that covers all 5 of those points. Okay, so that is how you graph a quadratic function that is in standard form. The beauty of the standard form is that it immediately gives us the y-intercept, and then using the components of the coefficients a and b, we can also use that to find our axis of symmetry and the x-coordinate of the vertex. Okay, hopefully that made sense to you. If any of this was not clear, please go back to the beginning of the recording and listen to this again. Thank you.